Engineers at the University of Nebraska-Lincoln have just unveiled a soft robotic muscle that doesn't just detect damage. It repairs itself. No glue, no tools, no human help. It's like artificial skin that knows when it's hurt and fixes the wound. Welcome to the age of self-healing machines. When I first heard about this, I imagined a robot patching itself with a tiny robotic band-aid. But what's actually happening is much more futuristic and way cooler. This self-healing system mimics how our skin works. It's not some science fiction dream. It's built, it works, and it resets itself after every injury. It even erases the memory of damage like a machine that it shrugs off battle scars. And here's the kicker. The process is fully autonomous. The robot feels the damage, heals itself, and prepares for the next hit, all without lifting a finger. 1. The 3-layer structure. This robotic muscle is made up of 3 intelligent layers. The top layer handles movement. It's like the muscle's brain, controlling action with water pressure, kind of like how hydraulic systems work. The middle layer is made of a heat-sensitive plastic. When it detects damage, it melts to fill the gap, then solidifies again, effectively sealing the wound. The bottom layer acts as a kind of robotic nervous system. It's packed with liquid metal droplets inside silicone that can sense pressure, punctures, and stress. Together, these layers make a system that's more than flexible. It's intelligent. 2. The healing mechanism. So, how does it actually heal itself? When the system senses damage, say a puncture or tear, the liquid metal forms a new conductive path, pinpointing the exact injury. Then it sends an electric current to heat up the damaged area. This melts the plastic in the middle layer and seals the break. Once it's fully repaired, the robot sends another current to erase the temporary signal, resetting the system for future use. It's kind of like the T-800 from the Terminator that can regrow flesh that has been stripped away from its endoskeleton. 3. No tools, no human intervention. This process happens entirely on its own. No human input, no external tools. It's fully automated and eerily close to biological healing. You could slash this robot with a knife, walk away, come back, and it's healed. Good as new, like if your iPhone screen could fix itself after every drop. 4. Liquid metal sensors? Yes, really. If liquid metal makes you think of Terminator 2, you're not wrong. The droplets in this robot don't morph into murder machines yet, but they do play a key role. These droplets can detect pressure and form new circuits in real time. That means the robot doesn't just notice damage, it understands it. 5. Why it matters. This technology has huge implications for how machines survive in the real world. Space missions, machines that repair themselves in deep space, priceless. Military robots, think durable bots that don't need constant repair. Healthcare prosthetics, artificial limbs that adapt and self-heal like natural skin. Disaster response, robots that can navigate wreckage and survive damage without intervention. We're talking about a new class of machines that don't just function, they adapt, survive, and evolve. 6. A step toward autonomous robotics. This isn't just cool, it's a necessary step toward fully autonomous robots. Think about it. If we want machines to operate independently in unpredictable environments, they need to be able to survive, and that means they need to heal. Right now, this tech is limited to soft robotics. But if engineers scale this up to other domains, rigid machines, autonomous vehicles, even humanoid bots, the implications get wild fast. Analysis and insights. 1. A future of resilient machines. The biggest takeaway here? Fragile machines are a thing of the past. With self-healing capabilities, robots can operate longer, adapt faster, and reduce maintenance costs dramatically. This could revolutionize everything from construction to elder care. 2. Skin-like machines blur the line. The more robots mimic biology, the harder it is to tell where machine ends and organism begins. We're building systems that feel damage, react, and recover, not unlike how our own bodies work. The line between artificial and organic is getting fuzzier by the day. 3. Liquid metal equal new nervous system? Those droplets of metal could be the beginning of robotic nervous systems. Sensors that don't just detect but respond and teach machines to protect themselves. This opens up a new layer of robot self-awareness, not consciousness, but physical autonomy. 4. From machines to organisms? This tech hints at something deeper, the convergence of machines and life forms. We're moving toward machines that not only look alive, but behave like living organisms. First, it's self-repair. Next, maybe self-replication. Evolution isn't just for biology anymore. 5. Lower barriers to longevity. Self-repairing components mean less downtime, lower cost of ownership, and greater adoption of robotics in areas where fragility was once a blocker, like wearable tech, personal assistants, or remote industrial jobs. 6. The ethics of self-sustaining machines. If a robot can feel, react, and survive without us, who owns it? Who's responsible if it fails to heal or reacts incorrectly? With autonomy comes ethical complexity. 7. Built-in survival instinct. This kind of tech lays the groundwork for primitive robotic survival instincts. Not in a sentient sense, but as programmed resilience. That's a step closer to machines that prioritize their own integrity in real-time environments. 8. A new design philosophy. Robots have long been designed like rigid tools. But what if the future is squishy, flexible, and alive-like? We're shifting from engineering products to nurturing organisms. I once spent $20 fixing a cracked phone screen. If my phone had this robot muscle tech, I could have dropped it, watched it heal, and still had money for pizza. Also, if a robot ever pats itself on the back for fixing its own wound, is that self-care? Future forecast. By 2027, self-healing soft robotics integrated into prosthetics and wearable tech. By 2030, autonomous disaster bots capable of healing after being crushed or cut. By 2035, liquid metal circuitry becomes standard in flexible electronics. By 2040, fully self-repairing humanoid robots capable of field operations without human support. By 2050, biohybrid robots with modular tissue-like parts that regenerate, blurring biology and engineering. So what do you think? Are we entering an era where machines evolve like organisms, or is this just cool tech with limited application? Would you trust a robot that can heal itself? Would you want one in your home or in your body? Drop your thoughts in the comments. Do you think this is the beginning of something big? Here at Tech Blitz X, we focus on AI and tech news. So please like, subscribe, and hit the bell for more AI and tech news. Because the machines aren't just coming. They're healing.